Okay, at this point, what I would suggest is when the software is ready to go, you can go ahead and balance the load and reset the extension. Now, in the data sheet that I sent you has the different loads that we want to record data at. And for tension, I'm going to grab my lab right here. Thank you. For tension, we're going to do 15, 30, 40, and 50 pounds. And so we're going to manually just hit start and stop to increase it to those loads. So the first load is 15 pounds. And the extension is not important. We're not really concerned about that. We hit reset so that if we want to bring it back to this point, it's easy. Let's remember to bring our stops very close. Last year what happened is somebody hit return to position accidentally, and it completely went down too far, and so this thing like bowed out. Luckily it didn't break, but if we would have had that really close, it would have prevented that from happening. And again, sooner or later we're going to break one of these things. With all these students working on it, I'm trying to get more of these just to be prepared, but let's do what we can to try to prevent that. So actually we're never going to go any lower than this, so I'm going to put it right there. Now the amount of stretch that we have is going to be minimal. I mean, we're not going to see very much, so let's put those right there. Now what I do is if you hit the start button right now and try to go up to that 15 pounds, it's going to take forever because there's slack in this. So what I do is, I'm just going to move it up, and I'm going to do it until I see a few pounds of force. Remember, we're eventually trying to get 15, and you could really just go up to 15 using this. It's just hard to do because it moves so much faster. So, and then I kind of use my hands. I see there's still quite a bit here. Watching that number there, the 0.4, right? There we go. So actually, see how fast it went up? So you got to be careful.
Okay.
So what I'll do...
I do like if I see 0.4 or something, I just hit start. It's gonna again take forever. If you
hit start now? No. Once there's any load, so ideally what you would want to do with this is get it to where it says 2, 3, 4, something like that. And then when you hit the start button, it'll be perfect.
Okay.
It's just that if there's any slack in there, it takes forever to get that out. I'm actually going to hit the down button to bring it down a little bit and reduce that 14 pounds just slightly. There we go. And then at this point, let's hit the start button and try to get to the 15 pounds. And it always appears like it goes a little bit more, so I shoot for like 14 and a half. But I mean, that's perfect, that's fine. So you'll notice on the data sheet there's a target load column. You'll give that to them, and then you'll be writing down the actual load as well, which would be 15.62 in this case. Okay, that's the starting point. At this point, what we're going to do is talk about what's happening with this equipment here. I'm going to turn on this lamp. We have to have a light source in order to view the reflection of light and see the light pattern. And for now, what I'm going to do is I'm going to take the video camera off so that we can just play around and see these different patterns of light. So I'll pull this off. What you'll both want to do is, as we work on this, you'll be looking through this polarized lens at the material right now. And if you both look through it, you should be able to see that color pattern. Can you see a color pattern? And it's best to have
this is just visible
light. It's good to have a very white light. Mm-hmm.
So this one is a filter.
It's a polarized lens.
Not filtered.
Not filtered.
Okay.
Polarized lens. And once it reflects off the material, it passes back through another polarizing lens.
Okay.
And there's also a device here that we'll talk about more called the compensator.
Okay, so this light's going here,
Mm-hmm.
reflecting.
Back through, and you're viewing through this or recording with a camera.
Okay.
Yeah.
So do you know how much of reflected light is this one? No.
How much is reflected? You mean like what percentage of light? I don't know. Yeah.
Ideally, 100%.
It's not 100%.
Yeah. Really, it doesn't matter. We just need some of it reflected so that we can see the difference in the refraction.
Yeah, just not for this experiment.
Oh, gotcha. Gotcha. Okay. You're thinking ahead of something else. Okay. All right. Let's talk about what those patterns of light mean.
Okay.
So the patterns of light, you want to think about kind of like a topographic map. So on a topographic map, you have these lines, and the lines indicate different elevations. And if it's a mountain that's going up, and you're looking down on that mountain, you'll see lines that are around the base of it, and then they get smaller and smaller as they get higher and higher. So the lines that are getting smaller and smaller on the inside obviously mean a higher elevation, but the spacing of the lines is also important too. If you have lines that are far apart in their spacing, that means the elevation is going up slowly. If you have lines that are very close together, that means the elevation is going up quicker. And obviously, if the lines start out to where they're spaced far apart, and then they start getting very close, that means that the elevation is going up in a non-linear fashion. The colors are exactly the same. Different colors mean different strain values, and the closer those colors are together, the faster it's going up. Now the colors repeat themselves. So first of all, when you have zero stress, the color is black. So in the area where you have black, so we should expect to see black kind of off in this corner right here, because that corner is relatively unloaded.
Oh,
and I'm going to look. Okay, right, so it's relatively black in that corner. Now what happens from there, and I don't have the colors memorized, but there are two documents that were sent out with the Photostress experiment. One of them was the actual lab handout, and then the other was a very short discussion about the photostress or photoelasticity method in general. And on that document, it shows you the different color bands. So the way it starts off is black indicates 0, and then it transitions from yellow to, and then I think I wrote the colors down. Where did I write it down? Oh, I was looking in a different document. But it goes from, it does have it here generally speaking. So black to yellow, then to red, then to blue-green, then to yellow, then to red, to green, so on and so forth. Mm-hmm. As those repeat, they are referred to as fringe orders. So every time you see the red repeating again, that's a new fringe order. And that's not critical to the analysis, but it's just good to know that these colors repeat. That's the main thing. So if you look through this lens right here and you start where the black area is, as you move into this area here, you should see it go from black to, what do we say, yellow, then to red, and then to blue. Hopefully that's the case. The colors won't be perfect. Sometimes the blue-green color looks almost black, and so that can be a little confusing sometimes. So, but it's, again, the key is to always start in a black area and go from there. Now we should also see the colors changing relatively quickly in this area right here, because that's a stress concentration. So as you get to that area, the stress and strain should go up. This actual experiment is titled stress concentrations. So it's a twofold experiment. We're really just going to validate experimentally our measurements of stress concentrations with the book formulas, but we're using the Photostress equipment to do that. So a lot of emphasis in the lab on stress concentrations. Okay, the other thing that I need to mention now is that in this particular scenario where we are pulling on this sample, we're looking at, if we were to look at a cross-section of the material right here, we would have the stress being equal to the force over the cross-sectional area here. Now, if you move into this area right here, you have the same amount of force, but over a smaller cross-sectional area, so the stress is going to increase. And we're going to see an increase at the edges on the left and the right side of that hole. So if you look in there, you'll see you'll see the color patterns changing quickly on the left and the right side of that hole, because that's where that concentration is. The book has formulas for doing that, and actually I've included everything they need in the lab handout in order to calculate those expected stress concentration values. Now, in order to make the correct measurements, we need to have the Photostress system oriented in the correct direction, because stress and strain right at the corner, or not corner, but at the edge, say the right-hand edge of that hole, the strain and stress are in this direction. I'm going to turn on a laser here that is for reference only, strictly for reference, to tell you, come on, let's see, where is it? Ah, it's down here. So you can adjust this laser over on the side. Again, it's strictly just a reference, and when you start using the Photostress equipment more and more, you probably won't even use it. And what it's indicating is, right now you're going to be measuring stresses and strain in this direction. So we need to rotate the polarizing lens to be able to measure in this direction. Okay, so I'm going to rotate this knob right here. Now, you want to hold the compensator on the bottom while you loosen this knob, because once you loosen it, it can move. Oops, and I need to actually tighten this down a little bit. Okay. So I'm going to rotate this, and there's an angular scale over here, but to get 90 degrees is easy. You're just going to go all the way. So that arrow is pointing on that, which there's two scales on here, but 0 and 90 are easy, either horizontal or vertical. We lost our laser, but it is vertical right now. So again, it's kind of it's not that useful. You really just look at this. If it's this way, that's 90 vertical and vice versa.
So I have a question. Is this number?
Okay, we'll get to that in a minute. That's going to actually help us to take these qualitative color bands and determine quantitatively what the stress and strain is. Okay, so at this point, I'm going to double check by looking through the lens. You should still see the color patterns changing rapidly, a lot of activity, I say, in this area right here. At this point, we're ready to make some calculations. This device, as I mentioned, is referred to as the compensator. And I'm going to start off by setting it at 0. And the students need to be careful when they're turning this. As they approach 0, they don't want to hit the stop. It stops at 0. They don't want to crank it hard and hit that stop. It can damage it. It's a pretty sensitive piece of equipment. It has a 9-volt battery in the back. If the battery dies, I'll have, when I set things up, I'll have a couple of extra 9-volt batteries. I have no idea how long they last. It's the same one that's been in there since we've had it. So, what is happening with this compensator is that, I'm going to pull it off here for a second. There's essentially a piece of photoelastic material here, and photoelastic material is also referred to as birefringent. And so there's a piece of birefringent material here, and actually if you look at it, you can kind of see some colors in it. Can you see any color in it? I can see it just faintly.
Yellow.
Okay, so there's some color there, right?
Yeah.
Okay. What this does is, and I don't understand it completely, but this material is stressed. It's been locked into position such that it's stressed. And I don't know exactly how they do this, but I believe that it's compressed. And somehow they do it in a manner that it's non-uniform across that piece. So this sample's in tension right now, correct? And it creates a light pattern giving us those different colors. Now, we've got this piece here that's compressed, and if we can adjust it such that it completely cancels out the effect of this right here, and we have a known stress value in that material there, or strain I should say, then we can determine what the stress is. So the handout or their documentation says it like this. If you've got an unknown weight and you're using a balance scale, what you do is you put your unknown weight on one side. Then you start taking known weights and putting it on the other side, and when it's balanced out, that's how you measure what the unknown is. This is exactly the same. You're adjusting the position of that known material and getting it in the right position such that it cancels out what's going on there, and by canceling out, we mean we see black. And then based on the position, and that's all this number is doing and telling the software, it's just telling it where that piece is positioned, because when you turn this knob, it slides that little piece up and down. And so at some point, when there's a known position, we're going to tell the software that's where it turned black, and then it does the calculation from there. That part of it, not terribly.
Can you say one more time?
Sure.
So, are the numbers telling us where it's getting black?
Yeah, so what you're going to do is you're going to sit here and look through that little window. You can no longer look through the big part, but through that little window.
When I see the black, I'll stop.
Then you'll stop, right. And again, all this is doing is moving that piece up and down.
Black already.
Okay.
But it's like the grayish and the black whole thing, but the grayish color is
Okay.
on it.
But, and again, we want to see black. Remember, when we analyze, we're analyzing a point. So we want to see black right on that area where we're interested in calculating or comparing the stress concentration values.
You mean at the very edge?
Mm-hmm.
Because there's a little black and then it becomes whitish.
Yeah.
It's easiest to do this. So to set this at 0,
Oh,
and then to continually watch it as you rotate this knob. So you'll both want to practice that. The operation of this is not difficult. It's the kind of the art in it is determining when it turns black, and when you get into the bending, it gets a little trickier. There's some other things that start to happen. But what I'm going to do is let's all, and I'm going to stop the video here. Let's all practice making that turn black